Hello, everyone. I'm Dave Demlow. I'm the Vice President of Product Strategy with Scale Computing. Been with the company many years. I'm going to focus in this section on container management and orchestration. So we're going to resume, kind of pick up the demonstration that Craig left off with the newly provisioned clusters. And from there, we're going to do some automation to deploy applications. I've got a few slides, and we'll kind of switch back and forth so that we can keep going as the provisioning is happening. We're going to cover some basics, talk about the concept of infrastructure as code, some of the automation interfaces that we provide, our REST API, and a new Ansible collection for Hypercore that most of the demonstrations are going to be based on. We'll try to spend as much time on the demo, and we're going to do a multi-virtual machine edge site desired state deployment. We're going to push out a set of applications to these systems, as well as verify the configurations, no configuration drift on some of the ones we deployed yesterday. We're going to deploy a bunch of different workloads from some container runtimes with our partners Avassa, and we're going to plumb that all up into their control tower. We're going to set up a K3s single node cluster connected into Azure Arc, and kind of talk about cloud native in general, hybrid cloud, and the different developer interfaces, the different control planes, and ultimately what we want to show is that Scale is the infrastructure platform to run your legacy applications, your cloud native applications, multiple applications with different developer tool sets and so forth. So just some basics, again, so we focused on kind of, all the upfront work you do to deploy the site. Here, we'll really talk about, day one, getting that application pushed out, the initial configuration of the cluster of the site, of the workloads, as well as touch on, some of those day end operations, particularly on the application side. Craig talked a lot about, the Hypercore level of, automatically handling node failures, capacity expansions, firmware updates, and so forth. So we'll focus on the application side, how you can rapidly deploy new applications, which is an increasingly common expectation of not just getting this out, but the reason people are investing in a scale-out platform like this is to meet those demands, to quickly be able to deploy new applications that come up, and we need to have this new thing in 1,000 stores, and we can't wait a year to roll trucks or deploy hardware. We need to be ready to go and know that we can meet those needs. So value of IT automation. Increased speed and agility is really number one, but reducing errors, improving repeatability, enhancing security, so being able to quickly deploy security patches, enhancements, so forth, and ultimately lower costs and achieve higher reliability across the entire fleet as a whole. So we've for years had and exposed the Scale Computing Hypercore REST API. It's always provided for a single individual cluster. Good automation to mass provision, customize VMs, automate steps, so on and so forth. We recently added cloud in it, which to the API. So not only can we deploy the application, we can basically take a totally unconfigured, and that's what we're going to do here. Ubuntu cloud image, give it everything we need to bring it up and running, give it its instructions, set up all the security so we can connect into it remotely after the fact. And that really gave us kind of that first step towards end-to-end to make it really simple and to make it really easy to operate across a large fleet. We recently released and built this Scale Computing Hypercore Ansible Collection, and this is really ideal. We're going to show it here for automating systems across many Hypercore systems, thousands of systems. It really doesn't matter, from provisioning the applications, configuring the cluster itself, deploying those applications, setting security and meeting compliance regulations, and ensuring that you're not you're correcting configuration drift. For those who maybe haven't used Ansible, it really is designed for IT operators. There's some code. We're going to run this all in Visual Studio Code, but it's not a developer-oriented tool. It's human-readable playbooks. You can really easily see what's being accomplished. And when Ansible's done right, I will say I do believe it is declarative and desired state. You build a really good set of playbooks and roles that lets anybody, including even an application administrator, say what I need for my application. I need these kinds of resources. Go redeploy the playbook. And in our design for our Ansible collection, we really stressed a lot on making sure that it was declarative, idempotent, so that these playbooks are heavily reusable and operate across a very large fleet.
So is this a collection that y'all maintain?
We maintain. It's open source. It's in our GitHub repo. It's on Ansible Galaxy, and we took the extra step of certifying it with Red Hat. So it's a Red Hat-certified Ansible Collection. So if you're using Ansible automation platform, they will support you in your automation and so forth there. So we really, kind of in the scale way of making Ansible, which is a complex tool set, easy. We tried to make it, really well design of the collection itself, and then making sure you've got the ecosystem of support.
And y'all keep it up to date.
Yes. Oh yeah. Yeah. Yep.
And do we have the REST API? Is that consumable in a Swagger documentation
Yes.
format?
Yeah. And that's so the REST API currently is exposed. There's actually built-in docs on every cluster, so you can go in the Swagger and even test drive the API. There also is there's a Fleet Manager API, which is not currently exposed for public consumption, but it is the basis of a lot of this that also has that kind of documentation and so forth.
Are there SDKs for the APIs?
I don't know. We have examples online, for the REST API. We have a wide set of examples for Python, for PowerShell. The Ansible collection itself actually has a really good Python client that they built in order to support. So you could also use that directly as well.
You're automating against Hypercore itself, not against Fleet Manager.
Currently, yes.
So the context is within that site only. Is that correct?
No, well, let me show you. And actually, I want to kind of skip through the slides, get into the demo, and at least get it started, and then we can talk while it's doing its thing. So the demo is we're going to set up actually all these 3 stores. So we're going to configure the cluster, some basic things. We're going to create a special secure user for our Ansible automation to use. We're going to set up a snapshot schedule. We're going to set kind of the cluster configurations, which could be site or geography specific. We're going to import some cloud templates. We're going to do Windows. I'm not guaranteeing we'll be done in the time. We're going to do a lot of Ubuntu stuff, which will be really quick, but we're going to take a Windows IoT cloud-based image, import it, clone it, maybe get it all the way connected to Azure. If we don't get that far, we've got some others that we're done. And then we're going to deploy a set of 5 applications using Ansible with Cloud Init. We're going to configure them with Docker and Avassa on one of them, with a K3s cluster connected into Azure, deploy a sock shop application, create some a contractor jump box that we want to make sure is offline by policy. So it'll be there, but we'll guarantee it's offline if so forth. So let me switch over and let's get this the fun stuff rolling. So, all right. So I guess one of the things to point out is, if you're familiar with Ansible, basically what we're doing here is I have created region 4 in my inventory. In this case, we're using static inventory locally. This is something you can pull from Fleet Manager, so this same information, including credentials and stuff. But we're going to run a playbook here against just these sites, which are the 3 we just provisioned and the systems that are sitting over there that are already provisioned. Let me first kind of show what the inventory looks like from the Ansible standpoint. So here you can actually see, this is my entire inventory. We've got, a bunch of different systems in region 1. These are all real systems, by the way. They're out there that we've deployed to. Some of these are in my house. Some of these are in our Indianapolis lab. The region 4 is here. You can see here the SCFM. These are my connected, getting, from Fleet Manager. So you can use Fleet Manager as a source. But let's get some fun stuff happening. And if you're familiar,
will Fleet Manager generate the Ansible inventory file?
You can pull it from the API. Yeah, that's one of the things we haven't exposed yet, but that's not in our public collection today. But yeah, the abilities are there that you could have dynamic inventory coming out of that. One of the things that is really cool is in the current released collection, there is an dynamic inventory plugin for Hypercore. So all the stuff that you can, when you're provisioning against site A, things like what credentials to use, what keys to use, grouping. So in part of this demo, we're going to go after we deploy the VM and just all these set of VMs to show that we can use Hypercore as basically that source of truth. We're going to run a playbook that logs into the VM directly, gets the credentials from Hypercore, deploys some additional containers, registers up to Azure. So we kind of have that end-to-end. That's where really the day 2 stuff comes in. When you want to use Hypercore as the way to how do I orchestrate into all these individual virtual machines once they're initially provisioned. So if you're familiar with Ansible, if you see stuff that's green on some of these, like the 240 and 243, those are the ones that are already running, so they're configured. So there shouldn't be any changes. I was gonna, if Craig was up, say, hey, give me some configuration drift for the demo. But if there are, if we turned off one of the VMs that was supposed to be running, it would be turned on and so forth. The yellow ones, so these are all orchestrating against our newly provisioned fleets. Let me switch over to my browser here. So we can see, so this is 444, which I don't know what order it is. It's already imported its first template. It's cloned our pharmacy VM, which is the one that's running Docker and Avassa. It's going onto our point of sale VM. So these will continue to run. And actually, I had logged into all 3. So these are the 3: store 444, 445, 446 are all located here. So they're all running through. The Linux stuff runs pretty quick. We'll actually go ahead and let me.
Question from this, right? So as the Ansible playbook is running, right? Another question back to state. It's sometimes those playbooks are not well equipped to handle a failure in this scenario, right?
Yeah.
What would happen with your playbook if this NUC were to go offline right now?
The playbook would just stop. And again, this is where the fact that we made such attention on making sure all the modules are idempotent, it would just resume. It would figure out any configuration drift, whether it just stopped and or not. So we've not found any situation where it would get stuck or not able to operate. And we even, another thing that was kind of interesting with Ansible was we really wanted to pass. What do we got?
No, he's unplugging it.
Oh, okay. Yeah, it'll just stop. I mean, it's fine. We actually had some of that yesterday in our trials. But passing back errors so that when something happens, like an API, recall that we pass back to the Ansible operator, to the logs. This is exactly what happened. Like somebody yanked your security out or things like that. Making
Internet failure.
Yeah.
Yeah.
Yeah. So we've got all of our stuff going, and so actually, I mean, once really these go through, these 3 Linux VMs are the key. By the way, so there were no ISO images, there were no templates on these. To kind of make them faster, they're all pulling it from my laptop, or they're doing an HTTP import. I've got the template locally. So we were kind of concerned with all 3 of these doing at the same time. The Windows image is about 20 gigs, so but we'll let that run, and we can look at some other stores here. But this is all up and going. Let me switch back to my slides here. We covered some of these. Again, we really made sure that the modules were really complete, well built, declarative, handled everything needed, so that you didn't need to have a lot of knowledge. So little things like our API will not let you delete a VM while it's running. So you could, the non-declarative way would be, well, check this, do this, build all the code loop to do that. We made sure our module handles all those kinds of cases. Things like you can't shrink a disk. So we area and tell you the proper error for that, through the playbook, versus, oh, you want to grow the virtual disk on the fly, and my new application I'm deploying, I need to grow the disk from 100 gig to 300 gig and push that across the fleet. That's a live operation, doesn't require any reboot. So there's really a lot of knowledge built into the modules themselves. So this is the list of the current published modules. So, managing VMs, managing cloning operations, import, export. So, how you get stuff in and off the cluster, setting up snapshot schedules. There's some new modules that are available now that have gone. That was the VM lifecycle is really our version 1. Version 2, we're now working on adding the cluster configuration stuff. And then actually we use some of this in the playbook for creating users, setting cluster configuration, changing things like that, so forth. Also, a kind of cool thing is a feature for virtual disk upload. So as opposed to, I actually set up a web server here to do this, but we have an API that we use currently for ISOs, just became available for virtual disks, where I can just say, take this file that's on my laptop, push it out over the API through the module into the cluster. So another easier way to do provisioning. We talked a little bit about dynamic Ansible inventory. That's, the inventory in general in Ansible is just a description of things you want to operate against. It can include additional variables. I use things like, my site name. I could have made it the same as the cluster name, but things like that I want to orchestrate. Credentials, or hey, maybe in this part of the world I want to import my templates from this web server or this location, or including things like where I want to connect into, or what I want to connect my Azure Arc into this availability zone. All those things can be easily encoded into the inventory. And then, as we discussed, Fleet Manager can provide site cluster inventory, and that'll definitely be one of the things that's high on our list to build the module that gives you all that kind of two-way directional of pulling that dynamically right out of Hypercore. Craig mentioned the secure link, where you can, we'll be able to drill down from the Fleet Manager level down to you're operating on one cluster. Our intentions are to also make that applicable for the API. So then you could basically orchestrate all against the Fleet Manager endpoint if you wanted to, and not require direct cluster connections or VPN connections out to each of the sites. I mentioned, so we're on Ansible Galaxy. Everything is open source. It's on GitHub. Really good documentation on there. I mean, you can cut and paste things right out of the examples. Everything I'm doing here, by the way, I have in my own personal Git repo. So these whole deployment scripts of using the cloud in it, deploying Avassa and so forth, or something people could borrow and steal, and we're happy to work with anybody on those. And then, as I mentioned, we did take the actual steps, and it's a quality assessment to actually get this our collection certified by Red Hat on the Ansible Automation Hub. So if you are using Ansible automation platform, which I do think, for large fleets, there's a lot of things you can get, in terms of the scheduling, the UI, data collection, things like, being able to have like ad hoc workflows that, hey, I fill out a form. I want to give the contractor VM for 2 hours, and they go in and get the right approvals, and then you run automatically an Ansible playbook that turns on their VM and gives them access and kicks them out in 2 hours. All those kinds of things get pretty easy there. So let's check back on where we're at in our deployments here. All right. So let's log into, I don't think it matters which one, but let's take our pharmacy. All right, and let's just do a sudo docker stats. See where we are at. All right, so we can see a couple of things here. We deployed via the Cloud Init the supd container, which is the Avassa Edge Enforcer agent. So that was part of my Cloud Init. I also in there put the run commands that you saw Frederick run when he actually registered to the site. I built that into my Cloud Init. So this is store 444. So I think we should be far enough along that if I search here, let me do a refresh. Hopefully we should see store 444 and probably 445 and 446 up here.
Can you completely customize the Cloud Init?
Yes, yeah. Let's see, store 4, let's see what we got. Yep, so we have, 444, 445, 446 are all automatically registered to Avassa. As part of that, I already had the deployment set up to deploy the Popcorn Manager application. So those are the other 2 containers that we're running here. That was all fully automated. Again, the supd was part of my Cloud Init. The other containers were deployed on demand by Avassa. And I did learn that they automatically update their supd container. So that's pretty cool. So if there's updates for that, I don't even have to worry about that. Let's take a look at our K3s cluster here. So, and let me just try cubes, get pods, see what we have running here. All right. All right, so yeah, we've got the basic Kubernetes stuff. We've got the sock shop deployment application running here. So we're good. Those were all part of the Cloud Init part there. And we still have Windows importing because it's a big, large thing. So, so let's look at, I guess, the other thing. Let me go back to my VS Studio code here.
So you're jumping around, and I know you
sorry.
have to jumping around to show us what's going on in the background. So can all this be pipelined?
What do you mean by?
So I run a command from one place, and a pipeline kicks off, and so I can say if it's declarative.
Yeah.
I can say I want this popcorn app.
Yes, I mean here I haven't done anything other than kick off the batch, the shell script, which basically ran an Ansible playbook command. So this is all one Ansible playbook with a bunch of roles. I mean I can kind of show you here like the. Let's see, we ran, it was fleet hypercore config. So this was the playbook I ran, which was basically operate against the edge group within my inventory, and I limited it to region 4, so we didn't do it across whatever the 20 or 30 clusters. And I just ran these group of roles. And each of these roles, for example, if we dig into, let's just do the point of sale. And this, I'm not actually a coder, so this would just seem like a reasonable way to, so everything I do with the point of sale, like first thing, like I run the Hypercore VM clone module. If it's not already created, then I need to clone it from the Ubuntu 20 image. I need to pass it all this Cloud Init information here. I need to do these run commands. If it exists, I don't care about any of that. I just go on to, well, is the disk? I want a 300 gig disk. Yes, it's 300 gig. I don't have anything to do. I want it to have 6 gig of RAM. I want it to have these tags. I want it to have 4 vCPUs. It needs to be running, power state start. And so this is my declarative state for that VM. But that's basically, if I also say I wanted to give the developer of this application access to just this role, they could have basically access to just change that without having access to my full deployment playbook. So it's kind of why I structured it that way.
I gotcha. Okay.
But yeah, this is all running at this point. As a matter of fact, to probably get on to the next stuff, we are at the point where we are waiting for Windows. So I'm just going to do a Control-C here because I do want to show something else here. So here's what I want to kind of show the day 2 stuff. So I broke out and ran this command here, which is using Ansible inventory, but this is where I'm using Hypercore as the VM inventory. And to keep it simple, we'll just look at what's on store 444. And you can see this is basically all being returned right from Hypercore. These are the VMs I deployed. They're in groups that are based on tags. So I think probably, well, you can see even above. So like up here, this Ansible group tag, anything with that is store apps. That's how you can, from Hypercore, pass into Ansible. These are the different groups and so forth. And same like the Ansible user Ubuntu. That's, how this inventory is generated. But then when you're executing across it, it's also returning things like the IP addresses that are provisioned and so forth. So you have everything that you need to orchestrate against that. So what I'm going to do here is run a playbook. And basically the key thing this playbook does is deploy another container. So it's going against store 444. Let me make sure. Yep, that was the one I logged into. And okay, so I ran that playbook, and again, this was using Hypercore as the inventory, logging in directly to this virtual machine, and deploying the CMS app container. So on this VM alone, I've deployed containers 3 different ways. And we always get some of our prospects are a little scared of containers. Here's 3 different ways just on this one virtual machine that both initial configuration, day 2, ongoing management, with Avassa and solutions like that. And so forth. So, and then we also deployed containers in that K3S cluster that we deployed as well. All right, and I was just going to show idempotence here. So in here, I'm just going to run the same playbook again, and since it's already, now it's green because that container's up and running, it's in its desired state. It didn't have to do anything there. So, and obviously I could use this to add containers, to remove versions and so forth. So I'm going to do one more in-guest kind of day 2 orchestration against all 3 VMs that I just provisioned, and this is to it's running a set of downloading some files with the Azure Management Agent. It's got the credentials to connect it into Azure Arc, which we'll switch over to here in just one second. And then this will let me actually manage these virtual machines through Azure Arc. If I'm a Microsoft shop and that's where I want my cloud control plane to be, or I want to give developer access, I can have access to all of these resources from within Azure. All right, so again, our goal is to really be a standard infrastructure to run both your legacy virtual machines, any kind of container runtime you want, whether it's, just individual Docker containers, whether it's, Kubernetes clusters. I'll show you at the end, switch over to kind of Kubernetes land, where I've got a whole bunch of different flavors that I've provisioned and so forth. But let customers use really whatever edge container management strategy or system they want. If it's Rancher, it's OpenShift, it's Avassa, it's Portainer, I heard was mentioned. Google Anthos on-prem. I mean, there's all types of different tool sets, developer interactions and interfaces. Our goal would be at this point to work with all of them. I mean, we do have customers that ask us, well, what do you recommend? What's the easiest? So on and so forth, and we can work with them on that. But do all that alongside their legacy virtual machines. Video management systems that generally are running on Windows with very large data sets to the containerized cloud.
Sorry, maybe I missed this somewhere, but.
Yeah.
The containers run directly on the Hypercore or in a virtual machine?
They're running inside a virtual machine that we provision. And and our goal is to basically make that virtual machine layer invisible. Ultimately, in this case, I just used an Ubuntu image and deployed it, and showing how with playbooks, we can manage that. We could update that. We could handle that. I do think that ultimately we will provide an opinionated, simplified, managed runtime just to make it a little bit easier. But so far, it's the requests we've had are so far more of, I need this stack, I want this stack, can I interface with X, Y, or Z? And so we're at the stage of making sure we can be Switzerland and work with all those.
So could someone running Avassa declaratively say that they wanted to run one of their I forget the names that they had, but one of their app devs on Avassa using the app dev side, if they had all the right permissions, could they say, I need to run this? And then as long as the nodes from Scale were plugged in and turned on, could they get the VM set up? Is there a way to make that happen from a pipeline that starts from the app dev all the way to Scale to pull up the hardware that's needed to put the Avassa stuff on it?
Oh.
And then put the app on it from Avassa.
That's an interesting question. Seems all doable. I mean, kind of the default is we'd love to have, Avassa or whatever, just sitting there ready to go. I mean, even if you're not using it, where it's like, you go to the Avassa control tower, start running your apps, and it's just ready. The Edge Enforcer's already running, and it just deploys its first container. I guess that would be the initial way to go. We have kicked around things like having it scale out, like, some knowledge where run a container that basically uses our API to okay, I need another edge enforcer. I need another edge enforcer, or some things like that. But getting that kind of chicken egg problem.
I think you're also merging personas, right? Like
Yeah.
application developers and teams don't want to know that there's a VM with 4 gig of memory or 6 gig. They don't want to make those
Well, that's my
decisions. They
question.
want
Like,
that
if I could just kick it off and say, I need to deploy this software to that site. Let's say
That they
that
can
the
do.
site, the only thing that's been done with the scale is it's plugged into and it's got network. And the little lights are ready to go.
Yeah.
Does the app dev's not going to ever see the scale GUI or anything to do with scale, and they're not going to see the ops version of Avassa, right? So is there a way for an application developer, if you've got all these sites you got to deploy to, as long as this is up and running, declaratively say, put my app on that site there?
Yeah, that would just, I think if I hear what you're saying is, it would just be tags. Like we would want to make sure, like just like we've done here, we just deploy an Avassa Edge Enforcer to every one of these things and a default application. But you could give any application developer, oh, you want to deploy some new application? They just go in, configure the deployment, configure the application. I think I put some tags in there of like if they're Hypercore, or they could be geography or whatever. So they would just declare that application. They would just show up out here. They wouldn't know or care whether it's running, what it's running on, or things like that. But I guess, yeah, there's the chicken and the egg thing of, from scratch, you kind of, we're going to provide the infrastructure management, we're going to provide a runtime, a VM and a container runtime, and the connectivity to Avassa to enable that plumbing, or, whatever other tool.
So can the ops view in Avassa see, would they be able to do that? Because they see through to scale. So can they work from Avassa versus working from scale to get it set up?
Yes. They wouldn't need to. I guess, again, there's the chicken and the egg. There has to be the enforcer for the site to exist. Yeah. And so, yeah, I guess the infrastructure team would at least need to provide that and the parameters. Yeah. I have to think about that if there's some way to,
count it as a feature release.
Yeah.
To be able to, as I deploy a new site at the scale level, that it notifies Avassa that there is a potential new site.
Right. Yeah. Maybe something like that. Both of us are very flexible APIs. We both have kind of that cloud control plane. We like each other, works well together. So yeah, there's maybe something we could do, and and then the runtime piece is pretty standardized, like we showed
question,
here.
please?
Yeah.
With everything that you've shown us thus far, who do you define as your competition? And what do you think you're delivering that uniquely sets you apart and you think is your strength?
Yeah. There's lots of ways of answering. Craig, feel free to jump in or whatever.
So I could answer that in 2 ways. I could take the Avassa approach. It's like they're going to try to do it themselves first, cobble together a bunch of different things, recognizing that if they're going to look at a different solution, we primarily run into VMware. That's the #1 competitor that we have out there. There are other companies that have kind of a hyperconverged product that are kind of a VSA architecture that don't scale down really to the size that would work necessarily out at a distributed enterprise. So we don't directly run into those in this environment. And then we also, I will say even kind of outside of those, there's kind of a new onslaught of HCI vendors out there where they're taking off-the-shelf components. Oh, here's a hypervisor, here's a storage layer, and I'm going to cobble this together and put my logo on it. And each of the checkboxes is there for all the features, but I think the missing ingredient is the orchestration engine that we provide that provides the intelligence for the Hypercore cluster itself. So probably a different thing that causes us to win in each of those unique competitive sets, but those are primarily the ones. Yeah, I see.
Helpful, thank you.
Yep.
SD-WAN, CPE, side of things like, in the US, Verizon with VNS, virtual network services, application environment with the RAFA container stuff on top of that, or smaller ones like Six Square, out of France, right? For instance, part of Econops that using the CPE environment to come in. So basically, the network functions coming in, and then eating the compute functions, right? And trying to go up the stack. Are you seeing that in the space now?
I would say that decision is made well before they ever start to talk to us. But yes, we are seeing that convergence as well.
Overlap.
Yeah, that overlap.
For retail stores, that's one of the big deployments as well. SD-WAN or Edge CPE is a platform, right? As it were. Do you see Nutanix anymore?
We do in kind of that regional data center style of edge deployment. If you're looking at that definition of the edge term, as you start to get a distributed edge, almost never. Yeah.
Okay. So anyway, I just wanted to kind of flip back to here and kind of close the loop on some of this. So our playbook ran. We deployed the Azure Arc agent on all of our new workloads here. So again, we're not going to go kind of feature deep, but this is one of those where we do hear and we've heard Azure, we've heard Rancher, we've heard OpenShift. Right or wrong, everybody's got their starting point that they want to look at. How do you play with? So and Azure's got some very interesting things. So let me go into Azure Arc, and this is kind of their how do I manage a fleet of Kubernetes clusters. So I mean, this is my entire fleet. I think if we filter on store 4, we should see several of those here. So we're managing Kubernetes cluster here, and this, if you've never used it, I mean, I as a Kubernetes developer can connect in with proper credentials. I can get Kubernetes API access regardless wherever I am. I mean, it's like I could be sitting anywhere and connect in, deploy applications and so forth here. Same thing on the server side. So let me go to just servers here, and let's do store 4. So again, we deployed agents in each of these. You see there's both Linux, and I should have some Windows in here. Maybe not I can't see what's behind here. Yeah, a couple of Windows that I did the registration for. And from these, there's a lot of common services from managing. Let me just pick one of these here. Controlling updates, collecting logs, setting security policies, within Azure. So again, we have talked to customers who Azure shop, they're used to using tools like this on-prem to manage their used to using this to manage their cloud infrastructure. They can provide a lot of the same tools and so forth out to the edge, including things one of the things I think is simple but kind of cool. Like we could SSH in regardless of where we're at to the VM we just provisioned and with proper credentials, and they have that magic network tunneling and so forth. One of the other things I wanted to show just real quick, and I think this is kind of interesting. So this is running on a different cluster, not here, but this is a Hypercore cluster in my lab is running Azure AKS Edge Essentials. And what's kind of cool, so this is a Windows 10 VM. They support on Windows 10, 11, and some server operating systems. But if you notice here, I ran in a PowerShell script a kubectl command, and it's showing me a Mariner Linux node. So it's actually using nested virtualization to run a managed Microsoft AKS version of Kubernetes, single node, cluster here, nested on Hypercore. And so, I think there's use cases for, if this is what you're using in different environments, or this is what you're using in the cloud, we want to make sure that we can run those kinds of things and provide the automation to enable you to do this at scale across a fleet. One of the last things I wanted to show was just similar capabilities. So this is Azure, Google Anthos on-prem. And I just have a small demo here where you can see I've got an actual GKE running Kubernetes cluster, but I've got some GKE on-prem deployed on Hypercore. And again, if this is my tool set that I'm used to, and I'm used to deploying, applications through this, or I've set up GitOps, configurations through these, I can use these tools as a developer to deploy things across a fleet, whether they're running, in any number of locations and so forth. So this, so we covered all the Azure integration. We talked about the Google Anthos bare metal. Other tools, IBM Edge Application Manager is a partner we've worked with, similar in some ways to Avassa. They do things a little bit differently. Obviously very Red Hat, but really our goal is to provide cloud-like management for this distributed edge with all the differences that it entails, and do it in a very automated, secure way.
A lot of retail stores, I think, as you and Avassa both said, are using sort of machine vision type stuff, right? So computer vision use cases, which requires the use of a GPU.
Yep.
And in your case, what you would do is you would do a pass-through, GPU pass-through to the VM.
Yep.
And I'm guessing with Avassa, that works now, which is Avassa containers on top of your VM, on top of the bare metal that exposes the GPU all the way through.
Right. Yeah. And then you would want to tag that.
You want to tag that
accordingly, so that what resources are available. So these little NUC 10s and the NUC 11s have a reasonable desktop class GPU that can do quite a bit of inferencing, things like that. So that's one use case. We do have some bigger nodes that are currently more geared for VDI, but with NVIDIA GPUs. And I guess another thing, we we talk a lot about cookie cutter. I mean, at these scale, I mean, you know, a lot of these deployments, I mean, we're talking to many customers that are, you know, tens of thousands of deployments. And while we want to make everything simple and treat it as an appliance, we'll build you an appliance that has the hardware you need or the footprint that you need or the software stack that you know, if there's tweaks in the software stack, I don't know if Scott's going to get into it. I mean, even some of our built-in monitoring stuff that we use to run our own cluster, we've made intentional things to make that more open, that we could start managing hardware that's not on the cluster or managing applications that are running, because we have really a great tool set for, you know, doing that monitoring, for gathering data and so forth. So those are, you know, some of the things that we're looking into.